Hello, it's Christian the CTF Noob again, and today we're going to have a look at the fourth behemoth challenge from OverTheWire. This time we're going to exploit a format string vulnerability. So let's get started with behemoth3. We start by connecting to the challenge server via SSH. And then have a look at the provided files. Since there is only the executable, we simply run it. The program asks us to identify ourselves and then waits for user input. I enter some random characters and receive a welcome message that contains my input. This already seems interesting. Now let's run the program with ltrace to see all library calls. behemoth3 starts by calling printf to print the identify yourself message to the console. Then fgets is used to read the user input. When doing the behemoth1 challenge, we learned that gets doesn't check the input length, but fgets does. So the call to fgets should be no problem. If you haven't seen my video on behemoth1, I'll link the full behemoth playlist in the video description. Now back to behemoth3. I enter my name and printf gets called with the string welcome, followed by a second call to printf, now with the name I entered. After that, puts is called with the goodbye message and the program exits with exit code 0. We saw that printf is called directly with user input, so we should be able to exploit this, since we can use format parameters in our input. Let's try this out and run behemoth3 again, this time without ltrace. When I enter 4%x format parameters, the welcome message doesn't show the actual input, but instead the interpreted format string. So we can exploit a format string vulnerability similar to what we did with Narnia 7. If you haven't seen my videos on the Narnia challenges, again I'll link the playlist in the video description. Back to behemoth3. We're trying to exploit the call to printf that directly uses our input. We already know that we can use the %n parameter to write to arbitrary memory addresses. But what can we overwrite? The easiest target should be the global offset table. A good explanation of an attack that uses the GOT can be found in John Erickson's book Hacking the Art of Exploitation. Live Overflow also did a great video in which he explains how the GOT works, and I highly recommend you watch it. But in short, the GOT is used to look up external function calls, for example when calling a function from libc. The GOT contains a mapping from functions to memory addresses, where these functions can be found. Of course that's not exactly true, but it's good enough to understand this challenge. Please have a look at Live Overflow's video to learn the correct details. Now let's have a look at the GOT of behemoth3. For this we can use the object dump program. We can see a couple of functions that are mapped to memory addresses. But which entry could we overwrite? We can't overwrite the address of printf because we need printf to format our input. fgets is used to read our input, so we can't overwrite this address either. Puts, on the other hand, should be fine. We don't need it to read or format our input, and since it's called after the call to printf, it's a perfect target. So let's try to overwrite puts at hex 080497AC. To make things easier for us, we start behemoth3 with GDB. At first, we need to find a position in the format string from which the parameters are read. For this, I run behemoth3 with 4 leading capital A's, followed by 4%x parameters. One of these should print 4 times 41, which is the ASCII value of capital A. This way we know where printf reads parameters from. After the 4 A's, printf directly prints the 41s, so printf will start reading the parameters at the start of the format string. If we now replace the 4 A's with the address we want to overwrite, we should be able to use %n to write into that address. Of course, the seg falls at 4, because we only write 4 characters before the %n, but at least we know that we are on the right path. So let's try to overwrite the GOT entry with hex AABBCCDD, which in detail is described in Hacking the Art of Exploitation. We start with the first byte, which is AA. Since we know that %n will currently write 4 into the GOT entry, we need to add padding characters to overwrite the address with other values. So I add %x to print 8 additional characters. But it seg faults at a weird address. What happened here? Well, of course, %x looks at the start of the format string to know which value it should format. Then %n will no longer overwrite the address we specified. So we have to add 4 characters of junk at the start of the input string, so %n can write to the correct address. This will now write hex 10 characters, which is 16 in decimal. Of course, this makes sense, since we write 4 characters of junk, plus 4 characters of address, and finally 8 characters of padding. And 4 plus 4 plus 8 is 16. We need to add more padding characters. To calculate how many exactly, we can use GDB. With the p command, we can print the result of a calculation, and /d will print the output in decimal format. So hex AA, the byte we want to write, minus the 8 characters of junk and address, should result in the padding width we have to add to the %x parameter. The result of that calculation is 162, so we add this as the width of the %x parameter, and the program segfaults as expected at hex AA. Now that we know how to overwrite the first byte, what about the remaining 3 bytes? After the %n, we add another %x for padding, which we know we'll need to define the number of characters we want to write. Then follows a second %n to actually write the next byte. The 2 new format string parameters we inserted now need more junk and an address to write to, so we add them after the address that the first %n writes to. If we run behemoth3 with that input string, it segfaults again at a weird address. Again, what happened? Of course, when adding more characters before the first %n, the padding offset changed, so we have to recalculate the number of characters we need as padding in the first %x parameter. For this, we again use the print command, but this time subtract 4 times 4, which is 16, since we write 4 blocks of 4 bytes before the %x parameter. If we add the result of 154 bytes as padding, the last byte is again AA, so we can calculate the offset for the next byte. For this, we subtract from hex BB the 16 bytes of junk and addresses and the padding of 154 for the first byte. We can then add the resulting 17 bytes as the number of padding characters for the second %x parameter. If we now run this, behemoth3 will segfault at hex BBAA, so we did everything right. On to the next byte, which we want to set to CC. We of course have to add more junk and the third address to write the third byte. Also, we have to add 2 new format parameters for padding and finally write the next byte. The padding of course is off again, so we recalculate the new width of the first %x. Since we added new junk and the address, we subtract 6 blocks, which are 4 characters wide each. This time the padding is 146, so we set it as the width and the first %x parameter. And because the difference between hex CC and hex BB is 17, we set 17 as the third padding. This now segfaults at hex CC BB AA, so on to the last byte of the address. We have to add 1 last pair of junk and address, which we'll also incorporate into the calculation of the first padding. Now with all addresses and padding fixed, we only have to add the last padding and write the last byte with %n. Now, this segfaults at hex DD CC BB AA, just as we wanted. We now know how to overwrite a GOT entry with an arbitrary address. Now we must find the address which we really want to write into the GOT entry. For this, we exit GDB and create an environment variable which will hold the shellcode we want behemoth3 to execute. Again, I use the one by Hamza MacLeod. Then I create a temp directory in which I can create the getEnv_address program to retrieve the address and the environment variable when executing behemoth3. In the temp directory, I create a new file and simply copy the source from Hacking the Art of Exploitation. Then I compile the program with GCC. Now I can run getEnv_address and see that the address of the env variable when running behemoth3 will be hex FFFFDEA6. With that address in mind, we can recalculate the paddings in our exploit string. We start with the last byte, which is A6, for which we need 134 bytes of padding. Then comes the E, for which we need 56 characters of padding. The first block of FF needs 33 characters of padding, and for the last block of FF we get 0 bytes of padding. Well, we must do at least 1 byte of padding, so we have to prepend 1 to FF and calculate the padding again. This way we can write 256 characters of padding. Now let's enter these calculated paddings in the input string we used in GDB. The addresses remain the same because they are in the GOT. Okay, so if we entered all these paddings properly, we should be able to call behemoth3 with this new input string. Well, it doesn't segfault, but also we have no shell. This seems to be the same problem that we had with behemoth1, so let's add cat to our input to behemoth3. Indeed, that was the problem. So we run whoami and see that we are behemoth4. Then we get the password for the next stage, and we're done. I hope you found this video interesting and could learn a little bit more about format string vulnerabilities and how to exploit them. If you liked the video, please give it a like, and if you want to see me solving more CTF and wargame related challenges, please subscribe to my channel. If you have any questions, feedback or other challenges I should have a look at, feel free to leave a comment under the video. Thank you and until next time.